Hey scholars, I hope this video finds you well. Today we are going to discuss triangle congruence. So we're going to basically look at a couple triangles and determine if they are congruent based on some information that we know about them. And we're also going to talk about how to write congruent statements. So make sure to take good notes and pay close attention. Let's get started. Now let's remember from our transformations unit, which we just completed, that if we ever transform a pre-image, so let's say we translate it or rotate it or reflect it, then it will result in a congruent image. Okay, so let's look at these two triangles. So the question asks, what transformation will map triangle ABC onto triangle DEF? Well, you can see that it would be a reflection across the y-axis. So we can see that triangle ABC is congruent to triangle DEF here. So whenever we're looking at triangle congruence, which we're going to be talking about this lesson, we can always try to think about it in terms of transformations. You know, can I rotate the figure onto the other figure? Can I reflect it, like in this case? Or can I translate it? Or any combination of those transformations. So understanding that will help us as we move forward. Now let's think about this problem. We want to name all the corresponding sides and angles of the two triangles. Alright, so first of all, we can see that if we just rotate triangle ABC a little bit and then we can reflect it. So visualize that with me. We can rotate and then reflect triangle ABC for it to perfectly match on to triangle DEF. So we can also look at the congruent angles. So angle A is congruent to angle D because they both have one congruence arc. B and E have two congruence arcs. So we know B and E are going to be congruent. So angle B is congruent to angle E. And then that leaves us with angle C and angle F, which have three congruence marks. So they are congruent angles to each other. And remember, when we're saying these angles are congruent, they have the same angle measure. So angle C is congruent to angle F. Okay, now the side lengths. Well, we know that A matches up with D and B matches up with E, right? Those angles match up with each other, just like we said. So side AB, side AB is going to be congruent to side DE. Now the reason I did not say ED is because A has to match up with D. Since I wrote A first, I need to write D first. Since I wrote B second, I need to write E second, since B and E match up with each other. Okay? So, make sure you get that. And those sides both have one tick mark, right? So, therefore, let's look at the two tick marks, BC. Well, B matches up with E, and C matches up with F. And we see side EF has two tick marks. So, BC is congruent to EF. So side BC is congruent to side EF. Alright, and then let's look at the three tick mark side. So side AC is going to be congruent to side TF. A matches up with D, C matches up with F, so I need to write that accordingly. So I'll say side AC is congruent to side DF. Since A is written first, D needs to be written first over here. Since C is written second over here, F needs to be written second right there. Okay? So we got to make sure that the corresponding points are all in the same order. They're written in the same order when we're writing these congruent statements. What we did was we wrote our first congruent statements. So make sure you get this in your notes. Corresponding sides and corresponding angles are in the same position in polygons with an equal number of sides. So we just looked at congruent triangles in the last slide, and we wrote down all the corresponding sides and corresponding angles. Two polygons are congruent polygons if and only if their corresponding sides and angles are congruent. Now when we state that two triangles are congruent, we use a congruent statement. So we got to write the order of the letters just like we did when we were writing the sides earlier. We got to write them in the same order, okay? So the corresponding parts, the corresponding angles and corresponding sides need to be written in the same order. Okay, so you can see this example. Triangle ABE is congruent to triangle CDF. So see how angle A matches up with angle C, angle B matches up with angle D, angle E matches up with angle F, and you can see that reflected in the congruence statement. A to C, B to D, E to F. Also side AB matches up with side CD, so AB and CD. Side BE matches up with DF, so BE and DF, and then side AE matches up with CF, so AE there and CF. They're in the same spots, okay? So corresponding parts need to be written in the same order. Okay, so now let's try this. Let's write a congruent statement for the two triangles. So we see that R matches up with F, T matches up with D, and S matches up with E, okay? And let's see. I'm just going to start with, I'm going to put this in alphabetical order. R, S, T. Is that right? Yep. R, S, T. Alright, so we got triangle R, S, T. Okay, and I can write that in any order I want. But then when I'm looking at this triangle, the parts have to match up for this triangle. So which matches up with angle R? Well, that would be angle F. They have a single arc there. So I'm going to write triangle F, and then let's see, what point do I need to write next? What matches up with S? Well, it's angle E. So angle S and angle E are corresponding. So F, E, and then I just have D left, right? So we see that angle with the tick mark in it. Sometimes you may see that, but angle D is going to match up with angle T. So I got T here, so I'm going to write D right there. So we'd say triangle RST is congruent to triangle FED. There's our congruent statement right there. Okay. Now, which side is congruent to side FD? Well, we can look at the triangles to try to figure that out. We have FD right here. But I could also look at the congruence statement written here. It says triangle DEF is congruent to triangle KJI. Well, if this says F then D, so F then D. Well, I should be able to look at the congruence statement and figure that out. So I can look at I then K. So side FD is congruent to side IK. Remember, we have to write them in the same order. Corresponding parts need to be written in the same order. Now let's move on to a concept called triangle rigidity. Basically, this just tells us that if the side lengths of a triangle are already given to us, then it can only be in one particular shape. See, these triangles have sides of 5, 7, and 9 units. We're not given units, we'll say units. And this triangle also has side lengths of 5, 7, and 9. Now, even though they're oriented differently, we could maybe rotate it, rotate this triangle onto that triangle. They may be like facing different ways, but they're still the exact same shape. And what we mean is all these angle measures are going to be congruent. So in between 5 and 7, I have one arc right there. In between 5 and 9, I have 2 arcs right there, so that'll be the same over here. And then in between 9 and 7, we have 3 arcs, so right here, in between 9 and 7, we'll have 3 arcs. So those angles are going to be congruent, those corresponding angles. So that's going to help us when we talk about triangle congruence. And our first triangle congruence postulate is side, side, side congruence. So that means that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are going to be congruent. Because there's a relationship that we'll talk about more between the sides and the angles, the side lengths are going to determine the angles in these triangles. Like I said, we'll talk about that more in the future. But that's going to make the corresponding angles congruent to each other. So just like we looked at in the last slide, let's look at let's look at angle A, and we have angle B and angle C. So angle A is in between the side lengths that have 4 and 7. So angle F is in the same position, the corresponding position in between side lengths 4 and 7. So angle D is in between 4 and 6. Well, angle B is in between 4 and 6. So I'm going to put two tick marks, or two arcs at angle D, just like angle B has. And then angle E is going to have 3 arcs because angle C has 3 arcs. They're both in between the 6 and 7 lengths. So we see that all the angles are congruent and all the sides are congruent. But basically, at the end of the day, what this is telling us is that if three sides are congruent, then those triangles are going to be congruent because those angles are also going to be congruent, like we just talked about. So that's side congruence, SSS. So let's look at a couple problems. Are these two triangles congruent? How do we know? Well, so we see a congruent side. We have single tick mark here, single tick mark there. So we know side AB is going to be congruent to side CD. We also see the 2 tick marks here at BC. So side BC is going to be congruent to side AD. Now, where this gets a little weird is, what about right here, this third side? Well, they share that side, right? So we have a third congruent side here. Okay? So we can say yes, these two triangles are congruent by SSS congruence. All right, now let's look at number 2. So are the two triangles congruent? Well, we see that this has 2 congruent sides. We see that AB is congruent to DE and that BC is congruent to EF, but we don't know if they have a third congruent side. So we can't say that for sure that that third side is congruent. No, we don't have enough information. However, if we did know that AC was congruent to DF, then those would be congruent by SSS. But since we don't have that information, we just have to say no, they're not congruent. All right, now before we finish up, let's talk about an included angle. An included angle is an angle formed by 2 adjacent sides of a polygon. So basically it's the angle in between 2 sides. Angle B is in between side AB and side BC. Okay? So angle B is the included angle of AB and BC. It's the angle in between the 2 sides. Next, congruence postulate. It's SAS, side, angle, side. The A stands for angle, the S stands for side. It says if 2 sides and 1 included angle of a triangle are congruent to 2 sides and 1 included angle of another triangle, then the triangles are congruent. So let's check this out. We see here that angle A is congruent to angle E. Also, AC is congruent to ED. And let's see, AB is congruent to EF. Okay, so we have side, angle, side congruence. Side, angle, side. Because the 2 sides are congruent, and the angle in between them, the included angle, right, is congruent. We have side, angle, side congruence. And so therefore we can conclude that triangle ABC is congruent to triangle EFD. Now let's finish this up about trying these problems. Which pair of triangles is congruent? How do you know? All right, well, let's look at these triangles. We see a congruent side and a congruent angle. If this is 90 degrees, that must also be 90 degrees, right? These are both right angles, so they're going to be congruent. We see the shared side though, right? So that side is also going to be congruent. So we have side, angle, side congruence. Side, angle, side. So we have SAS congruence here. So yes, these are congruent by SAS. Now let's look at this problem. We have 2 triangles, and we also see that they share a side. So we know that this side is going to be congruent. So I'm using 2 tick marks because this has 1 tick mark. All right, so now I see there's an included angle between these 2 sides, these 2 congruent sides. So it looks like we might have SAS here. However, when I look at this triangle down here, the angle is not in between these 2 sides. It's not an included angle. It's on the outside right here. So if it was right here, then we would have SAS congruence, SAS, but it's not there. It's on the outside. It's not included. So we have to just say not congruent because they're not congruent by SSS or SAS. I hope that lesson was helpful for you. I know it was a lot of information and it was kind of long, but to be prepared for class, just be ready to practice writing congruent statements and identifying if triangles are congruent by SSS or SAS congruence. Good work today. Thank you, collegiate scholars.